Hello? Um,
Hey, Miss Sonia, how you doing?
good.
Cool. All right, we'll be on in a second. I'm putting Sky in. She's sick today, so a couple of other people coming in.
Okay, so we were on the
Yeah. Oh, I wanted another try. You did. So you're good. That's all I ever asked for was a try. At least the first go around with homework, you know? You never know. Sometimes it's easy and sometimes it's not so easy, so.
She told me to tell you, and I'm like, I won't forget.
No, she texted me too. I don't know if she told you that, but she did.
No.
Yeah, she texted me too and was like, oh, we're having some issues here.
Yay.
Make sure this volume is down over here. And make sure the volume is down. Hey, Ren.
Hey, what's that name?
What's shaking?
Nothing.
Say hi, that's Ren.
I don't care what you're doing,
Nice. Say hi, Ren.
Hello,
Old staff round with your tail back. Lily's his buddy. Oh, yeah. You like the shirt? Uh-huh. Let's see. Yeah, right. Welcome. Yes, of course.
Oh,
How have you been?
good.
You got the corona fatigue too?
Yeah, I mean, I got some extra time off. I just took a couple extra days, so.
Good for you.
Here, I'll just, have a few extra days here and there, a few extra Mondays and Tuesdays and, Fridays.
Good for you. Enjoy it. You
Yeah.
should.
Yeah.
Hi. Hey, girls. Oh, good. We have warm donuts.
All right, well, have a great day.
Yeah, you too. See you later. Wait to see you for a second fair.
Bye, ladies.
Isn't it Tinker? Yes. Well, so here is the deal. Collins apparently decided that they weren't going to hold Tinker Day until the spring because of coronavirus. To which I said, oh no, can't happen. Coronavirus has taken enough. That's it. I want my Tinker Day. So we're having our own Tinker Day. So I'm gonna set up some donuts in there, and then we'll take the computer over
Does that
there.
mean that we're watching the educational meeting?
We're gonna do some fun stuff. I'm gonna turn Sonia around so y'all can see her.
Last Tinker Day was magical.
Maybe.
Tinker Day is where you can eat a bunch of junk food and watch a movie.
Why is this frozen?
And it's magical here because everybody's doing like junk food.
Actually, we do some class, but why is this not doing its thing?
Oh my gosh, yay. Ozzy! I love you. Oh, Ozzy, how cute you are.
You can sit there, it's fine. We're gonna do a lot on the computer too, so. I'm trying to figure out what's up with this thing. What say? Reverse camera. All right, there's Sonia over here. If y'all want to turn around and wave at her. She's there, and Sky is there too. Look, she's looking at the back of the bill. Like you have to turn around. Hi, Sonia. Yeah, we're going so funny, crack me up. All right, let me bring a couple things over there, and we're gonna get some donuts. Over here for a minute. Oopsie. My phone wants to fight with me. My computer wants to fight with me. Alrighty, so I got most everybody. All right, y'all, give me just a second. I'm gonna roll out our special Tinker Day donuts.
Make sure the volume's down on here though.
Well, you play on that. S-D. J.
I think this guy's annoying every
No,
game
no,
that
all
comes
I
out.
heard.
This guy's overplaying.
S-G. S, oh my god, why can I not?
S-D.
G. J. J.
S-G-J?
I'm just when can I learn this?
I went to the did this.
Oh,
And then I did.
I'm gonna tell you right
Maybe I
now.
should write
I already got it. Okay, ready?
D.
D. I. X. Q.
D-I-X-Q-Q?
You know what? Oh, Z. D. I.
Well.
Okay, y'all.
No, I would want to remember what you got to go in.
Why don't we go over to the dining room for a second and let me give y'all treats. How about that?
No, please.
Like, in the. Or like.
Why don't y'all go on over to the dining room real quick? We'll get some Tinker Day. They stood up. Gee. Crazy, because that's Ozzy. All right. Come on over here, y'all. Okay, so we have Tinker Day this morning. Oh, goody, Miss
Oh, that's all I.
She's coming on. That's exciting. Hang on.
You too.
I needed to bring.
I don't know. Well, you didn't know. Neither did I.
All right, so good. Miss Jocelyn's on. Let me switch this camera around. So we're supposed to have Tinker Day in October of every year, right? There's supposed to be a Tinker Day, right, Jocelyn? There's
Yes.
supposed to be a Tinker Day. Jocelyn feels my pain. Does your mom do Tinker Day with you?
She hasn't in the past, but when I
Didn't- oh,
said
shoot, hold on, my
older,
computer's being weird.
Lily, you know how we have
Why is it being like that?
She's gonna have another cat friend.
I know.
And I'm already teaching her how
Oh,
to,
it's being strange.
how when, like if Ari was sitting where Ozzy is sitting, if I tap my leg and walk away, then she.
All right, so anyway,
That's what I'm teaching.
here's what we got today.
When she,
Ta-dum.
I call her.
All right, so guys, listen up. So every October, we're supposed to have a Tinker Day where they cancel classes at my college and everybody hikes up a mountain and it's really fun.
I hate my mountain and get lost.
But the problem is that apparently they canceled it this year because of COVID and said they would do it in the spring, which I thought was completely and totally unacceptable. So here we are.
You gotta wait until next year.
We're gonna do our own Tinker Day. Now, when they do Tinker Day,
I want donuts.
listen, when they do Tinker Day in the spring, you guys can totally do the dressing up thing that I mentioned in the email and get the extra credit. But today, we're just gonna do some donuts. If you wear green and gold, or if you send me a picture of you eating a Krispy Kreme donut, or if you get a right proper Tinker Day costume, then you're good.
Know it's a Krispy Kreme thing. Oh, we probably have to hold it.
Yep, all right, look, so I'm going to go grab, I got some milk and some chocolate milk.
And you guys can grab a donut.
I like up kitty.
Yeah, I like up to MHA.
Yeah.
I was talking. I like up anywhere to get to that field.
I will
Literally.
And then we go ahead and get started on our lesson. So, all right, here we go. You can pour yourself a glass of milk or chocolate milk. You can grab you a donut. You can take them into the living room if you don't get it on stuff, okay? Go ahead.
I'm
We
good.
had a bunch more stuff.
Go ahead.
These are cups, okay.
Oh, that's when we do our
As a
Christmas
guest,
time
I
party.
get to go first.
We do our Christmas time party. That's always fun. Go ahead. Somebody start. I don't care who's doing it. Just
I'm
somebody
good.
start.
You're not getting
You don't want a donut, Jules?
No, I don't like donuts.
Okay.
I want a donut.
Me too.
Yeah, chocolate milk and milk. You can have one of those.
I have a smoothie.
What are we gonna do about our masks though?
Just
eat with your mask.
I want a donut, but I don't have donuts. I don't think. No, I don't have.
It's like
I love how nobody's
yeah, you can't yell at Dick. I know. He's so scary. How could you ever get mad at Dick? Almost said it.
Boy.
There you go.
Okay.
Miss Danny, can you virtually send me a donut?
I wish I could. I want to figure out how to do that. You're supposed to have donuts. Your mother is slacking if she's not getting you donuts every October. Tell her I said so. Well, most people don't. And they're missing out on the world's best holiday.
Wrong.
Here, quick.
What's the world's best holiday?
Tinker Day.
Christmas. He's gonna say Christmas. I think Christmas. Oh, on Halloween. The only part I like about Christmas is
That's okay. I'm gonna grab me one too, and then we'll come over here and we're gonna do our thing.
Or eating all the We get the same damn thing.
It's where they didn't get themselves in a situation like Africa, like kids, like certain kids in North Africa and third world countries. Actually, only I'm supposed to do that. No, yes, that didn't get themselves into that situation.
All right, I got mine now. I'm good to go. We've done
Miss Danny.
like most Tinker Days. I'm sitting so far from you guys, so I'm gonna breathe air. Plus I'm eating.
People like,
Huh? All right. Well, hello
Miss
there,
Danny.
everybody.
people wear special clothes.
I'm trying to see if I can get that volume thing figured out. It's so strange. Who else is here that, are we all good? Good, good, good. Hey, Sonia. All right, so I would have shipped, okay, y'all listening? I would gladly have shipped donuts to Senya and Jocelyn had I thought they would have kept, but I don't think it would have arrived too nicely. So find you some donuts today because this is our fake Tinker Day since they're not going to give me a real one. I'm seriously bummed out because I feel like 2020 has taken enough from us and we need some flippin' donuts.
Already taken trick
I need my Tinker Day. All right,
Miss
so
Danny.
here's what we've got. Today's lesson,
Miss Danny,
huh? I heard somebody. Never mind.
it
All
was
right,
me.
so what you got, Jocelyn?
It's fact that Halloween, the price of not price, but like the amount, the people that don't know how to word this. It's fact that Halloween, like Halloween decorations aren't really being bought and candy's not really being bought. And some countries actually like they banned door-to-door trick-or-treating.
Wow, that's ridiculous. Like craziness. We're still gonna do our trick or treating, but it's gonna be. Hey Cole, your dad's on phone calls all morning and he asked for extra quiet. All right, thank you. I'm just telling you, y'all are chatting. All right, so we really do need to get rolling on our lesson. I had to fix the audio over there. All right, are you guys with me now? That we're all sugared up? Okay, so here's the thing. Some of you guys probably had a little trouble with the balancing chemical equations. Did some of you? Yeah, it's new. Okay, so we have an activity today. We should have plenty of time after lab to work on it. Yes.
Danny.
Oh my goodness. Oh my gosh, Drew, what I say to everybody. Okay, you know what to get. Take care of it. All right, so here we go. We're going to talk about our balancing chemical equations and stuff today, because that's definitely probably was a challenge for some of you guys, huh? Yeah. So I actually have an activity after lab today where we're going to
get my dad's help for that.
so we're going to balance, we're going to use marshmallows and we're going to use them and move them around. I thought about that kind of last minute, but what I'll do is I'll send you guys that aren't here, I'll be sure to send, there's a PowerPoint that shows you the steps, and you don't have to use marshmallows. You can use Skittles, M&Ms, Fruit Loops, anything that's got a couple different colors.
Ooh.
Should be fun.
Sour Patch
All right.
Kids.
There we
Airheads.
go. Airheads, yeah, if you've got enough of them. So a chemical, and it doesn't have to be food either, you can use beads. A chemical equation shows a chemical reaction using symbols instead of words, right? Drew, you're gonna need the fabric cleaner for the couch.
I know.
Okay, all right. So you guys figured that much out. I'm sure you guys understood when looking at them that it's basically, it's using symbols instead of words. So in this one, you would read it as, CS2 plus 3O2 yields, that's what the arrow is, CO2 plus 2SO2. Or you could read it as, if you knew what these were, like this one's oxygen, right? 3 zeros. So 3 oxygens. Let me make sure that's not somebody trying to get on. No, it's not. So if you knew how to name them, which we worked on a little bit before, you could actually name them because like right here, this is 3 oxygens, carbon dioxide, right? Right. So what does a chemical equation contain? So it always has your reactants on one side. Sometimes it's more than 2. It can be 3, it can be more than 3. And then it has the products on the other side. And again, it doesn't have to be 2. It can be many different things. So we have subscripts and coefficients. Does somebody want to give me an example of a subscript in one of these pictures? Which one is a subscript? Anybody see one? The subscripts look like this. They're below. Like a submarine.
I was about to
Okay.
say they both look the same.
So a subscript tells you how many of that atom or element are in the molecule. So if you look right here, see where it says 3S2? That means you have 2 S's, but you don't have 2 C's, right? CS2, but you only have 2 S's. Now, if you look at the next one, it says 3O2. This is an oxygen, but how many oxygens are there?
3.
2. There's 2 here, but then how many units of 2? How many pairs? 3. So how many total oxygen are there?
6.
It's 6. It's multiplication. So you have a
I was
pair.
about to say 4, but I'm like, that makes no sense.
There you go. So now you have your coefficients. Now these show relative amounts. So these are the ones in the front. So like right here, you have SO2, but there are 2 SO2s. So you have 2 and a sulfur, and then you have 2 oxygen and a sulfur. So when we do our activity with with the marshmallows, you'll really be able to do that. Like you'll really be able to make it work. And it should make a lot of sense once you see it with your eyes and move them around with your hands. So the law of conservation of mass, remember what that is? What
It's the law saying saying that matter cannot be created nor destroyed by
or
any
mass?
any
Right.
physical or chemical mean.
Good. So now we have to talk about a closed system. So closed system means there's no external stuff going on. So if you had a bottle with a lid on it, everything inside of it is a closed system. And the mass within there is going to be constant no matter what, because it's in a closed system. The elements may shift around, they may change into different things, but it's going to stay constant. So think about this. If you have a bottle of Coke, okay? I have to say Coke. Sorry, we're in Atlanta. It's got to be Coke. It can't be something else. You got a bottle of Coca-Cola. All right. Now you've got the liquid, but there's also a gas dissolved in that liquid, right? And it's what gas? You know? Yeah, you said it. Carbon dioxide is dissolved in it, right? So now if you keep the lid on, that carbon dioxide isn't going to get out. It's all in there. If you open the lid, what's going to happen?
Kablooey.
Yeah, what happens when you open a Coke? Do you see bubbles? Right.
Yes.
Yeah. Now
but
open
if you shake it up, you'll see more bubbles. It would actually probably.
That's true. You will. So yeah, you've got your system, and now you've opened it, and you've also by doing that, you've also lessened the pressure that's keeping that gas dissolved in the liquid. So then you'll see the bubbles start to form, and you'll see the carbon dioxide leaving.
Danny.
So yes.
Can I tell you an accidental experiment I did?
Oh boy, yeah, go ahead. I'm wondering if it involves the freezer.
I was putting my mom's beer in the freezer, and then I left it in there
Doesn't
for
involve
2
the
days.
freezer, I knew it.
And then it kind of like popped and exploded.
If you leave a beer in the freezer for way too long, it will
Or a
pop.
soda, anything carbonated. And that's because
Trust
the
me, I know
water-
from experience, because my dad loves putting the
Yeah.
beer in there, and I always have to check on him.
most matter will contract when it gets cold. But if you remember, water expands. And it's because it forms the crystalline structure all of a sudden, which means it stretches out. So if you have water contained inside a can, a little flimsy aluminum can, and it expands in there, it's only going to expand, but so much before it goes boom and bursts out of the can. And then all the carbonation is released. So you get this like bubbly, frothy, frozen mess, right? Everywhere. We used to keep our drink
Yeah.
fridge on the back porch. Outside on our deck, we had a screen porch, and we kept the drink fridge out there. And it got really cold one night, so cold that it was colder than the inside of the fridge. And I came out in the morning and like 20 cans of Coke had exploded. It looked like a cavern. Like, so yeah, if you've got a closed system, then your matter's not going to be created or destroyed, and it's going to stay in your system. Now, let me ask you this. If you took a bottle of Coke and you had a really, really, really good scale, like a really precise one that, could get your measurements down to itty bitties, many, many decimal points. Could you take the bottle of Coke, get the mass, take the lid off, leave it for a day or so, then put it back on the scale with the lid? Would you get a different mass or the same mass? What do you think?
Different mass.
Yeah, because what has now left the system?
The
All the carbon
carbon.
dioxide. You got it. All right, so we have 3 types of chemical reactions.
It has no pop when it comes
Right. It's flat. Yep, it's terrible. We have 3 types of chemical reactions here that your book describes. Now, I want you to know there are way more than 3, but there are 3 that are the big ones that you guys are going to learn. So here's what we have for you guys. We've got synthesis reactions. So what's a synthesis reaction? Does anybody remember from reading? Thinking. So a synthesis reaction is just what it sounds like. It's when you take 2 or more elements and you put them together and you make a more complex substance. So if you took hydrogen and oxygen and put them together and made water, you would have a synthesis reaction, right? It's when you are synthesizing things. Cool. You are creating, right? So that's the idea of a synthesis reaction. You've also got a decomposition reaction. Now, what's that one? Anybody know?
I'm still in synthesis.
Oh, it should switch for you in a second. Did it go?
Now it has.
There you go. Does anybody know what a decomposition? What is it, Eleanor? Let them all get one first, and then if they do them. So a decomposition reaction is the exact opposite of a synthesis reaction. It decomposes. And what does it mean to compose? It means to put together, right? If you compose a piece of music, you put all the notes together, right? If you compose an essay, you put everything together. So it's literally decomposing. So it's coming apart. So you take your compounds and you break them down into simpler products. And if you look, this is actually a picture of hydrogen peroxide decomposing. And if you remember last week, we did the little fizzy stuff in the big tall round bottom flask. It's called a volumetric flask. So we had all those bubbles, and that was because we had a decomposition reaction, or hydrogen peroxide decomposed, but we sped it up with a catalyst that was yeast. That makes the reaction go faster. So this is hydrogen peroxide decomposing, and there's probably a catalyst in there because it looks like it's going pretty quickly. So what do you think hydrogen peroxide would decompose into? What's it sound like it would decompose into? Hydrogen peroxide. Hydrogen
dioxide.
Hydrogen and oxygen is what it's going to decompose into. Hydrogen and oxygen, which is interesting because you can put hydrogen and oxygen together and you can get hydrogen peroxide, or you can get water, right? Just depends on how you put them together. What's the combination? All right, and the other kind we have are these replacement or displacement reactions. So yeah. That's true. Okay. So if you have a replacement, displacement is typically what they're called. You can have one element replacing another in a compound, or two elements from different compounds switching places. So there are two different types of what we typically call displacement reactions. There's single displacement and double displacement. And single displacement is when you just have one compound like joining with another. And then your double displacement is when they're swapping places. Now, there's one I'm going to do next week just as a little demo that I'm going to show to them, but I'll make sure that you guys see it too, because it's really cool. And it's a double displacement where you can take, if you have silver nitrate and copper 2 sulfates, solution, you put them together. No, it's just silver nitrate. You have silver nitrate and you put in a copper wire. And what'll happen is there is a really fast reaction. You can watch it happen, which is really neat. But it literally will pull the silver out of the solution and attach it to the copper wire. So it looks like the copper wire is growing silver hair. It's really neat. And it happens really fast.
It's
cool. Very, very cool. It's very cool. There's also a decomposition reaction that I plan to show you all next week that will be a demo outside called the Screaming Gummy Bear. And it's pretty cool. It's a decomposition
Why
reaction.
is the gummy bear screaming?
Well, you'll see.
Hey, Danny.
Yes.
This kitten is actually up for adoption.
Oh, well, where'd Lily go? Because that looks like Lily needs that kitten, right?
And he has,
Well,
and he has two
her mom's a
brothers.
vet. Oh my goodness. Ella says her mom's trying to adopt a kitten.
Yes, we need it. We need it. We need it. Is it like
His
a
name
baby? Is it a baby?
Is it a baby?
Because we
Yes.
need a baby for it and our other cat to grow up together.
Oh, there you go.
It's me.
Bring that up.
2 months old, 3 months old.
Is it cute? Want to get another animal? Definitely get a cat.
Yeah.
Don't get a fish. Don't eat it. Don't get a dog. It has 2 fish lizards.
Get this kitty.
But don't give it to dog. Because that's just animal care.
It's animal cruelty to the
No, we
dog.
already have
Some
2
dogs
dogs.
like cats.
We're
Now,
gonna
they
get
don't
2
get
dogs and 2 cats. We already
Just our
have 2
dog.
dogs. We used to have 3.
Trying to get this one, she can
Rest
so
in
they can
peace,
see, 'cause
Bailey.
it's weird.
And it got killed by a deer, we think.
That's
So.
right.
We think it either stomped on it or stabbed it with its
Here it
teeth.
is.
It was a coyote. What?
There.
How do you know?
Camera was being strange on me and it went to sleep and I don't know why.
Yeah.
So yeah, so anyway, Senya's mom is a vet, so she's got some animals. All right, so
He also
look at these.
has 2 brothers.
Wait a minute, shh. What'd you say, Senya?
He also has 2 brothers.
Oh, he's so
Is it a
cute.
baby? No.
He's a baby. Yeah.
Yeah.
All right, so
Yes.
look at these two. Do you see these 2 volumetric flasks? One of these is a closed system and one of these is an open system. You guys tell me which is which.
Blue is
The closed system is the green one.
There you
Because it has
go.
a
That's
cover on.
right, because it's got the lid on it. Very good. Very, very good. So something you always have to consider when you're doing chemistry. If you're doing chemistry out in the open, which most of us are, otherwise we're like in some kind of a weird vacuum bubble that doesn't exist, then you've always got to contend with the atmosphere, right? You've always got to contend with the air around you and realize that just the air and the water in the air and all the different elements that make up air. What's our air mostly made of? What element is mostly? Not carbon,
Oxygen.
nitrogen.
Duh.
actually. There's air that- nitrogen, oxygen, hydrogen, all that stuff is in the air. Carbon dioxide, carbon monoxide. Yes.
H2O.
Go ahead.
Did you know scientists
Drew. I'm trying to hear Eleanor. Go ahead.
are trying to make a portal to fictional worlds?
Oh, that would be
I
fun.
didn't know that.
It depends on the fictional world.
I want to see the I want to go to
Who is
All right,
everybody
so-
screaming?
Yeah.
Hey, y'all. Real quick, I want to go over. I want to show you what your answers are. Hang on a second. Show you what your answers are for last week's notes, and then I want to go over some balancing equations with you guys here, and then we're going to use the marshmallows later. We'll put our hands on them because the lab is quick, so you'll have time to work on the marshmallow stuff after that.
Miss
All right,
Danny,
so- yes.
I think giving them donuts was a bad idea.
Look, they're all laughing. They agree. They totally agree. All right, so did anybody get an answer for number 1? Did anybody give that a shot? What'd you get, Ella?
Yeah.
Oh, no? You guys want to try one? That's okay. So here's what we got. Well, there's others, so we'll move along to them. All right, so here's what we should have for number 1. It's FeS, 2HCl yields FeCl2, H2S. And this is what we call a double replacement because they're both different. Don't worry if you don't have this totally understood yet. You guys are not going to be as responsible for it as the older group. Drew, are you checking your notes? Check your notes.
2H.
There you go. Yeah. So these are kind of hard if you've never done them before.
I
What'd you
tried. I probably got everyone wrong though.
That's okay. So what'd you get for number 2? Anybody get number 2? What'd you get, Lily? Oh no, on the describing chemical reactions part.
I
That part.
got.
Ella, you get something?
And then I don't know.
There you go. So Ella so here's what we got, 2Na. So if it's just by itself and it's not part of something, you usually put the coefficient in the front instead of the subscript. It means the same thing, but that's just kind of the way they write it. And then the F2, and then that's backwards, sorry. And then the 2NAF at synthesis. And then here's the last one. I'll just put them up. You guys just look at them, but don't worry about it because we're gonna go over it in just a second.
Oh, wait.
Just give you guys a chance to see what's there. Don't fret over them. All right, so looking at we're just looking to see what anybody got, but I'm not freaking out if you guys didn't get those 3. They're just kind of to give it a shot.
Less than 11.
It'll get, yes. I don't think anybody won Rico last week because a lot of you didn't hand in stuff.
I
So-
think so.
I think you did, it's at your spot if you did. I don't know, I'll have to double check because everything got graded late. Yep, everything got graded late last week because I had to put the video together. All right, so let's look at 6 through 13, okay? All right, Drew, you with me? 6 through 13. Who has number 6? What is chemical equation? Ella, what you get? H. So that would be bunk, bunk, bunk. Uses symbols and formulas to show chemical reactions. Perfect. We're on number 7. What page number? All right, let's send you do this one and Jocelyn can do the next one. Okay, send you do number 7.
I think that this one is G.
G. There we go. Very good. Decomposition reaction is with compounds are broken down into simpler substances. All right, Jocelyn, you want to do number 8?
It's F, number telling how many molecules of a substance are involved in a chemical reaction.
Perfect. All right, who over here wants to do 9? Jules. Jules says number 9 is A. Good job, Jules. A product is a substance present after a reaction. All right, 10. Who wants to do 10? Ella, you do 10.
E, a substance present before a reaction.
That's good. Reactants before reaction. How about Drew? Do you have number 11? Synthesis what tapped it? Whoops, sorry. I gave that one away. How about you do number 12? Because I just accidentally tapped. Number 11 was B. You have 12? Oh, you can't find it? What page is it, guys? I don't have the page out in front of me.
Lesson 11, number 3.
3, page 3. Lesson 11. Okay, Lily, you got 12? D. That's right. A replacement reaction is a reaction in which one element replaces another. And 13. All right, Ella, go for it.
C.
C.
Principle that states that matter is not created.
Perfect. Now you found it, huh? All right. So now let's have a look here at how to balance chemical equations. So we're going to go through a couple steps, okay? And then we're going to practice with the marshmallows later. But we're going to go through some steps now. And let's see if it makes a little sense to you. So here's the equation we're going to work on. We've got some irons and some iron oxide, and carbon. And then we're going to end up with iron and carbon dioxide. Okay, so how are we going to get there? Step number 1 is you're going to draw your bracket. All right, and this is how you draw your bracket. That's easy, right? everybody can do that. All right, so then,
Wait, what is this holiday called that we ate donuts for? What is it called?
Tinker Day. Tinker Day is the best. You have to Google it. It is so. So if you want to follow along and have your pencil out, it might help to draw this stuff as we're going because it can help your brain connect it. So you might want to pencil. So we're just looking at the screen right now. I don't have any, there's nothing in your book really to go over this so much. So the first thing you do is draw your bracket. And if you don't have your formula written, you might want to write your formula. There you go. Yep. Now it's definitely tricky if you're having to type because putting in subscripts and subscripts aren't too, coefficients aren't too hard, but subscripts are harder. But do you have a pencil, Drew? Do you want a pencil? You should probably get one. There's one right there in my bin if you want it. All right, so you're gonna draw your bracket like that. And the next thing you're gonna do is you're gonna split your equation in half like this, okay? You're gonna put the reactants on the left and the products on the right. And that's easy enough. Now comes the part where you have to start kind of counting your atoms. And this is actually really not hard at all. This part's easy. So you're gonna write the total number of atoms of each element on each side of the bar. But the thing you have to remember is the order. You're gonna do metals and then non-metals except for hydrogen and oxygen. And then you're gonna do hydrogen and oxygen last. And as long as you can remember metals first and hydrogen and oxygen last, you'll be good to go, okay? So our first metal right there is iron. Hey, Cole, can you guys keep it down a little? Okay. So you got your iron. Then the next thing you have is your carbon. And then last is oxygen, right? So how many irons do you have? You look up here in this whole side out of everything here. And you go, well, I've only got 2. All right, I'm gonna write 2. And how many carbons? I've got 1, I'm gonna write 1. And how many oxygens? 3. Now you can do it by compound. I like to do it by compound. If I've got, especially if I've got more than 2, I like to break it out into little chunks and do like my irons and oxygens here, and my carbons here have a different column. But it's all the same in the end because it's gonna balance. So you're gonna do the same on this side. All right, now here's where you gotta think. So you have to look and you have to say to yourself, all right, well, how many oxygens, how many irons do I have on each side? Well, I have 2 irons here and I have 1 iron here. And we're talking about, talking about conservation of mass. So we can't take anything away. We can only add. That's the only thing we can do.
Oh, 3.
So, well, that would be how many we have in total, but that's not what we're trying to do. We're trying to get the left side and the right side the same. So we're gonna balance the metals, then the non-metals, then the hydrogen and oxygen. So you can't change subscripts. So these things right here, the little numbers, we can't change, but we can add or change coefficients. So we can put some in the front. So if you add a coefficient, what you have to look at though, like say we put a 2 right here in front of this Fe2. Yeah, well, if you put, but if you put it here, what you have to remember is that now I have 4 irons and I have 6 oxygens. So if you're trying to balance one of these elements, you might end up adding, and you got to kind of keep going back and forth. So the first thing we're going to look at is the iron, okay? So we have iron, and let's say to ourselves, well, 1 iron over here isn't going to do us any good. I need 2. So in order for me to have 2 irons over here, I have to go back up to my equation at the top, and I got to make that a 2. Now I have 2 iron. Yep, that makes sense, right? Okay, now I have 2, and I have 2, and you look at it and you go, all right, good, check, we're good there. Then we got to move down to carbon. All right, we have a carbon and a carbon. This looks good, right? And when we put this up here, we didn't change anything with the carbons. So we're good. All right, excellent. But now we got to look at our oxygens. We have 3 and we have 2. There's our 2 right here, O2. And here's our 3, O3. So how are we going to fix that? So here's where you have to think. Yeah, so this is where it comes in. This is algebraic thinking. This is like how algebra works. So it's basically you have a quantity, you don't know a certain quantity, and you have to figure out how to balance them out. So what we're going to do is we're going to take this 2 and we're going to get rid of the 2 and we're going to make it into 3 so that we get 6. So the way we're going to do that is, because the easiest thing to do, guys, is to look at the two numbers here at the bottom. You have a 3 and a 2, and they multiply together to make what? 6. 3 times 2 is 6, and 2 times 3 is 6. So if we multiply 2 times 3, we're going to get 6, right? And if we multiply 3 times 2, we're going to get 6. So this is your lowest multiple here. Your 3 and your 2, your lowest multiple is going to be 6, right? So if you multiply them together, you're always going to be right. You may have to like get some weird big numbers that you work with, but it's always going to be right. So if we do that, we're going to put the 3 up here because we multiplied this by 3. Now we have 6, right? We have 3 times 2 oxygens, 6. Perfect. So now we're going to go over here. Well, that's got to go by 2 in order for us to get 6. So we're going to go put the 2 right there. All right, well, now we have to go back up and look. So we got to say, check, check, we got 6. All right, but now we have to go back to the beginning again and make sure that we didn't change anything, because we did, didn't we? When we put this 3 here, we changed how many carbons there were. And when we put the 2 here, we changed how many irons there were. So you have to go back and say, well, okay, now what did I change? All right, so looking at this, we go back to our first metal and then go to our non-metal and move on like that. So let's see. Well, now we have to go back to the beginning and figure out what we've done. Well, we don't have 2 irons anymore, do we? We have how many? How many irons do we have?
4.
We have 4 irons. So, okay, we got 4. All right, now, yeah, now we have 4 there. And how about on this other side? Are we looking at that? We don't have 2 irons anymore, do we?
Nope, so we
No,
need to
we
put a 2. We need to
That's
put a
right.
small 2 next
That-
to E.
Or we can just change this coefficient to a 4. That's the thing to do. You got the right idea, Senya. That's perfect. So does everybody see what happened there? We had 4 here.
Yeah.
So we have to have 4 here. So we go 4, 4, check. We got it. Now we got to look at the carbons. We have 1 carbon. We have, we don't have 1, do we? We have how many? We have 3.
3.
That's a problem. So we got 3 carbons here. So how do we make 3 carbons over here?
We multiply by 3.
That's right. Got to multiply it by 3. So we're going to put that 3 right in the front. Now we have 3 carbons. 3 carbons. 3, 3. Check. Beautiful.
But
And
then we have a
down here.
2.
We have a 2 where?
By
one you
the
look
carbon.
This one or this one? This goes with the oxygen. So you're good. Yep. So now we look and we go, oxygen is 6. Oxygen is 6. All right. We did it. And that is a balanced equation.
Yay!
That's how it works. So I'm going to show you guys a run through. You can practice them here. If you haven't already done this, this is great. Practicing them on this is wonderful because this website, what it does is, can I make it go? It does a really good job of helping you when you're new at this because it shows you what you need to balance. So like, for example, if you go to the beginner level here, what it'll do is it'll very nicely tell you, look, this one needs to change. So if you look and you say, I have 4 hydrogen, 2 times 2 is 2, 2 times 2 is 4, 2 times 2 is 4. I have 4 hydrogen. Great. I have 2 oxygen, 1, 2. How many oxygens? I have 1, 1, 2. But it'll tell you what you need to change as you go through, which is super helpful. But what I wanted to show y'all was, oopsie, I can't close my thing because that's in the way. So here's how the marshmallow bit works. And those of you that are at home can, I'll post this so you can practice with it. But it works like, where are they? I'll show you the first one and then I'm going to start lab because I have to do that for everybody else. So here we go. This is how it works. You're going to get marshmallows and every time you just designate what they're going to be. So for this equation, you put them down here so they're not in the way. We're going to assume that sulfur's yellow, carbon's orange, oxygen's green. How many green marshmallows do I need to put here to represent O2? 1. And how many of those are there? How many O2s? Look right here. 3. 1, 2, 3 O2s. Got that? Okay, now we've represented that one. How about this? How many carbons do I have, guys?
1.
1. And how many sulfurs do I have?
2.
2 sulfurs. Perfect. How many carbons do I have here?
1.
1. How many oxygens?
2.
Perfect. Okay, now how many SO2? So here's an SO2, and how many of those do we have?
2.
2. Okay, so you have SO2, SO2, right? So now you just count. 1, 2, 3, 4, 5, 6. 1, 2, 3. So you start with, it's okay. Start with your sulfur and say, you know, you got 1, 2, 1, 2. You can kind of look at these and see that this is already balanced, isn't it? 1, 2, 3 sets of 1, 2, 3 sets. That's 6. 1, 2, 1, 2. Boom, that one's balanced. If you look at another one, yeah, I had smiley face. If you look at another one here, for example, there's your Cl2, NaBr, NaCl, NaCl, Br2. Then you go, okay, well, I gotta add one here because I have 2 here. 2 orange, 1 orange. Okay, 2 pink, 2 pink. And now we put the 2 there because we have 2 NaBr. And look, you did it. See? So that's what we're gonna go over after lab a little bit, but I'm gonna send this out for you guys at home to practice, okay? Hang on. Oh, the mole was last week. But we have to get started on our lab now. So I'm gonna let you girls go, okay? We'll see you on Alec, wherever he is, not just girls, and Sky. All right, you guys, see you later. Bye.
Bye.
I'm gonna buy the kitten.
All right.
You will get the kitten.
Y'all are funny.